Hello and welcome to lesson 6 of the atomic structure booklet, the periodic table. Have a go at the do now, pause the video, then come back and we'll read through it together. In this lesson then, we'll be looking at how we can describe the arrangement of elements in the periodic table. We're also then going to explain methods to order the elements and how they've changed over time. And then finally, we'll be able to link the element's properties to its position on the periodic table. And this is a really important lesson and a really important concept, because really if you can use the periodic table, then you can do a lot of things in chemistry. So understanding of the periodic table and how it works is vitally important. A chemist's toolkit. The periodic table is one of the greatest inventions of humankind. It orders, in logical sequence, every element in the known universe. By using it, a chemist can predict the properties of an element, how it will react, its mass, density, and other physical properties. In the modern periodic table, elements are arranged in order of increasing atomic number. Atoms of elements on a periodic table contain one more proton than those preceding them. For example, atoms of lithium contain 3 protons, and atoms of beryllium contain 4 protons. Elements are further placed in periods and groups. Periods are the rows of the periodic table. Across a period, certain patterns repeat. Columns on the periodic table are called groups. Elements in the same group have similar properties. They react in certain ways because they have the same number of electrons in their outer shells. For example, all group 7 elements have 7 valence electrons, and all group 1 elements have 1 valence electron. Let's pick out some important points from that passage then, ladies and gents. So, it's important to know that on the modern periodic table, elements are arranged in increasing atomic number. So we should definitely highlight that. It's also, and we've got the example there that lithium contains 3 protons and atoms of beryllium contain 4 protons. Remember, atomic number tells us the number of protons in the nucleus of any element. This next section says elements are further placed into periods and groups. We need to remember that periods are the rows of the periodic table. We should also remember that columns are called groups. Now, it's called the periodic table because across a row, so across a period, patterns repeat. And you'll hear people say that the patterns repeat periodically. So across that row, the patterns will repeat. Elements in the same group have similar properties. So that means that they're going to react in certain ways, in similar ways. They're going to have similar properties, physical properties such as density, etc., etc. And they react like this because they have the same number of electrons in their outer shells. So elements in the same group have the same number of valence electrons or electrons in their outer shell. So anything in group 7 will have 7 outer shell electrons. Anything in group 1 will have 1 outer shell electron. What I'm going to do now is give you a chance to have a go at Learning Activity 1, Appendix A10. If you need any support with that, there's a link to the video where I go through it with you coming up on the screen now. When you've had a go, come back to this video and we'll carry on with our read through. Developing the periodic table. So chemists spent many years attempting to order the elements in a logical way before Dmitry Mendeleev devised the precursor of the modern periodic table in 1859. So we've had the modern periodic table, or something very similar to it, for just over 100 years now. But before that, there was a lot of different attempts by chemists to try and order the elements. We're going to have a look at some of those now. So an early attempt was made by John Dalton, who wrote a list of known elements and their atomic masses. His table included many substances we now know to be compounds, and he used alchemical symbols rather than the modern symbols we now use. So alchemy was a kind of old science that's been around for thousands of years, was based on the idea that you could turn base elements, so things like lead, into gold. So this was in the very early days of scientific development in Europe. Subsequent examples of arranging the elements relied on placing them in order of atomic mass. Dobereiner suggested that elements came in groups of 3, or triads, in which elements had similar properties, but this could not satisfactorily order the known elements at the time. Another chemist, John Newlands, suggested that the pattern of similar properties occurred every 8th element. He ordered them into octaves, being an ancient word for 8, a term he borrowed from music, but this also failed to predict the properties of heavier elements. So in here it's important to know that Dobereiner came up with this idea of triads, also that John Newlands thought that there were octaves, and that octaves were repeating patterns of 8. So both of these were good for a few elements, but they broke down when you got a bit further into it. Finally then we come to the man himself, Dmitry Mendeleev. Dmitry Mendeleev was a Russian chemist who solved the riddle of how to arrange the elements. He wrote the names and properties of all the known elements on cards and tried to arrange them by atomic weight. He realised that if he strictly followed the order given by atomic weight, then the patterns stopped occurring. Mendeleev realised that there must be elements yet to be discovered. This caused him to leave gaps in his table where he thought undiscovered elements should be. He was so confident that he even predicted the properties of these missing elements. His theory was finally proven when gallium was discovered and its properties matched those of his predicted element Eka. We now know that the position of an element in the periodic table relies on its atomic number, and that the repeating pattern of chemical properties is due to the number of outer shell electrons an element has. When Dmitry Mendeleev proposed his periodic table, electrons wouldn't be discovered for another 38 years. That really just goes to show the genius of Dmitry Mendeleev and what a powerful insight he gave us to the world around us. So it's important to know from this bit that Mendeleev realised that there were elements to be discovered. And what he did then, like all great scientists, he came up with a prediction. So he predicted properties of these missing elements, which immediately gave chemists a way to test his theory. And although it took years for an element to be discovered that he had predicted, when that was finally done, gallium finally proved that Dmitry Mendeleev had been correct all along, and that was the real insight. So there were some small differences between Mendeleev's table and our modern one. For example, Dmitry Mendeleev didn't know to include any noble gases on the table, as they hadn't been discovered at the time. But largely, what Mendeleev came up with was very, very close to the periodic table we use today. Hope this has been helpful to you. Join us next time, where we'll look at lesson 7 of the Atomic Structure booklet.